All right. Hello, everyone. I hope you're having as much fun as I am, because this is the first real conference back after the thing that I'm to, and it's everything I wanted and so much more. So my name is Jakub. I'll be talking about how to make your API design and development process less painful. In particular, I'll talk about how to do that with Smithy and SMITHY4S, and of course, I'll say what these are, but later. If you want to see the slides for this talk, they will be available at the link below, also my contact info. So this will be also at the end of the slides, but link3/Kubicos is it. Without further ado, let's get to the topic. Just a quick sound check. Is everything sounding all right? No echo? Cool. So we will have three parts of the whole thing. We'll talk about first common mistakes and problems in API design and implementation, what causes them, and what the outcomes can be. Then we will talk about Smithy, just in general, what the idea is and what the thing does. And finally, we will try to connect that to talk about how Smithy helps solve these problems. Spoiler alert, it's not going to be a silver bullet, but hopefully it will help in some of these issues. So as the first thing, as I mentioned, we need to talk about problems. And in particular, I want to talk about problems with API design and implementation, which is where the problems begin. You can still say the problems that we encounter in production have a technical nature, but they all start at some point with humans. Problems start with us because we are not perfect. We are not machines, and we make mistakes. That's normal, that's to be expected. And first and foremost, we make mistakes when we talk to each other, when we try to communicate. And there's no second meaning. This is just pure human-to-human communication. We talk to other teams, we talk to our stakeholders, and I really hope you do this as well, but we talk to our users. If you don't talk to your users, you probably should. We talk to these people and we decide what needs to be done, when and why. And there's a lot of room for mistakes in this communication. And it's very costly because this is very early and you decide on the whole direction of the project or the API that you're going to implement. And if you get it wrong here, then it just gets worse and worse. The impact can only be bigger than anything you can mess up later on. And it's not that you're doing something wrong. It's not your fault usually. It's just communication is inherently difficult. It just is. There's no way around that. And there are many reasons for that, like language barriers or cultural barriers. There's body language. Some of us are just not able to read as many body clues as others. There's implicit bias. There's opinions, because when you're opinionated, it may be hard for you to change your mind or put yourselves into somebody else's shoes and see the situation from their point of view. And then there's just errors, communication errors on the human level. Maybe you just misheard something, or you forgot to write something down, and you just missed something crucial in the process. And this is all, again, before we even start writing code, so mistakes at this stage can be very costly and kind of catastrophic, really, to the project. One of the things that you can get wrong is requirements. So you may not get the idea of what the user wanted. You may just implement the wrong thing. This sometimes comes up when you try to build a solution before you fully focus on the problem that you're trying to solve. And maybe someone expects our API to be something that we don't want it to be, or we are trying to use an API that in a way that it wasn't meant to be used. So just this kind of thing. Then there's something smaller, maybe not as catastrophic, but you can submit certain details, like someone specified a field that it was required as an input in some sort of endpoint, and you forgot to send it. Or you think something is optional, but it's not. Or you think something is required, but it's actually optional, and you're assuming too much. Or you're assuming more properties from like a text field. Maybe you want it to be a certain length, but that isn't the reality. That isn't what you discussed before with your users, your clients, or whoever's calling that API. And finally, the worst of all, you may just be focusing on the wrong problem. You may be like over-focusing on a solution that someone wants to implement without a clear reason to implement it that way. So maybe you just don't understand the whole problem, and you just really want to have a specific thing without actually understanding why or how this is going to solve someone's problem. It's just not going to have impact on the users, it's not going to make their lives easier, and it's not going to deliver any value. This is similar to something called the XY problem. And to give you an example, someone may suggest that, okay, we need to build a function that gets the last 3 characters of a file name. What they want in reality is get the extension of the file name. So that's a completely different thing. Like, in some cases it will be the same, but it's really something much bigger and something that you need to consider upfront and not just implement the first thing that comes to mind. And getting this wrong, like doing the wrong thing, is a massive waste of time for you, your team, and your organization. So yeah, we need to try to avoid that. And these are not even all issues that can stem from communication or communication issues, but this should give you an overview of what can go wrong and just some sample ideas. And the sooner you catch these, the better, as always. And there are many more kinds of problems that can result from mistakes and ambiguity in communication, but let's imagine we get through all of that, and we're about to start implementing an API. What can go wrong on this stage? First, we have typical writing problems, so typos and just forgetting things in the implementation phase. So the output of this could be like your client or server will not match each other, and you will just have incompatibilities at runtime. And it's sometimes hard to discover until it's too late. You may only find out about these when you deploy to a test environment, or sometimes you don't have a test environment, so you find out in production. Best place to test, right? But yeah, it's another way to delay your project because you don't have feedback early enough, and you are doing manual work, repetitive work, which isn't what we're meant to do, really. And you just get it wrong, which is normal. Then we have documentation problems. I'm not sure how everyone here views documentation, but I like to think it's important and it's useful. And sometimes you're just missing documentation. So that is bad, but it's actually, like my personal opinion, it's not the worst thing about documentation. It's worse when it exists, but it's wrong. If you have documentation that doesn't match the reality of what the server is doing, then this is actually worse than having no documentation at all, because you don't know what to expect completely. At least otherwise you would have known that there's anything can happen, or what you will find out is the truth, and here you can trust docs that are not entirely accurate. And this doesn't happen just in basement projects that you make with yourself or with your colleague. It happens in real life in technologically mature organizations as well. So it's not a rare issue. And finally, problems that show up even after you deliver your API, because this isn't the end of the software development lifecycle. You still need to maintain that API. You still need to extend it, and at some point, possibly, hopefully, deprecate and remove it. And if your API implementation process or your maintenance, all your processes around building and maintaining APIs are manual, then it may be hard to detect change and react to it. It may be hard to detect changes that are breaking, and teams who need to adjust to your changes may have a hard time catching up, because there will be nothing that will tell them, okay, you are using the latest versions, you are not using any deprecated stuff. And it will just make it more difficult to evolve your APIs to get rid of these old deprecated things. And all of these things can be fully, or partially at least, solved if you have a good tooling that works with you. So here's where the Smithy language shows up and solves some of our problems. So let's take a break from these problems that talk about it. So what is Smithy? Smithy is an interface definition language. So surprise, it's just designed to define interfaces. And it's a very small language, has a very limited number of features. And for example, the language itself has no details of like HTTP or anything like that whatsoever. There's no syntax for HTTP features like endpoints or methods or URL parameters. But we can add them in something called metadata or traits. But we can add extra information to a specification of an interface using some features of the language. But basically, we define our APIs in terms of operations, which have an input and an output. We can say what types will show up in the input, what types will show up in the output. We can say which ones of them are required, and give them names, and so on. And first and foremost, we focus on the data, the interface, and the domain, which I think is really nice because it allows us to focus on the important part. And the HTTP thing, we can still refine that later on, or we can start with the interface and only then say, like, this is going to be this HTTP endpoint or something. I'll have an example of that later on. We can then group these operations into services. This is just like a list of operations. And the language, even though it has a small number of features in itself and very small syntax, you can extend it with some of these extra details. Now, this isn't something I made or someone made in their basement. It has been created by AWS some years ago. And they use it internally to build APIs. I'm not sure if like all APIs or some APIs, but they definitely have enough usage to keep a team working, an entire team working in this language. They use it in SDKs. So the Java, Node.js, and Rust SDKs use Smithy sources to generate code from, and this is what you run when you actually use these SDKs. But it's not just a language meant to be used with AWS APIs. You can define your own APIs using this, and you can call them without even deploying to AWS. For example, Disney Streaming, which is the company that created SMITHY4S, is using this. SiriusXM, which is my current client, is also using this. So, and there's many more companies that we probably don't know of, which are getting into it or using it more on a larger scale. As I mentioned before, the language is simple and protocol agnostic because there's no HTTP in the language, but there are these things that you can slap on your API and just say, like, this particular parameter is going to be an HTTP header. And this is when you introduce like protocol or transport-specific details, but it's still not like a language feature. This HTTP header thing, I could have defined this in my own Smithy sources. It just happens to be in the standard library, but it's not a new language construct. So, yeah, I talked about this already. You can put as many of these hints or traits. These are called traits, but we can call them annotations here. Maybe it will help things. You can slap as many of them as you want on something, but whether it actually gets used and how is up to the interpreter of your specification. And you can define your own interpreters. So if you are an organization that, for example, prefers to use XML than JSON, you can do that. You can build your own interpreter and apply this to all your APIs for your clients and your servers alike. Now, the really cool thing, which I think is huge about Smithy, is that it is readable for machines. It is a declarative language, which means we can parse it. There's actually tooling for that. We can parse it and get an accurate description of our API, which is a data structure. And it turns out that we can do quite a lot of data structures. We can look at them, we can analyze them, and we can possibly change them, like return a new copy of them, so make some transformations on our API. But we can analyze them without having to understand features that a language like Scala has, like conditionals or loops or functions or pattern matching. None of that exists in the language, so it's much easier to analyze what happens in it and to get a complete view of the entire API in a data structure. So the benefits of this are that it is really easy to build or extend tools based on this language. You can precisely interpret whatever someone specifies, and you can, for example, generate code from it, which will actually look like you want the code to look like. You can also use this to define and enforce certain API standards, like consistent ways to version your APIs inside your organization, or make sure that all the error responses have the same sort of general shape. And yeah, so this is in contrast to something that other approaches may do. So in the case of, for example, HTTP4S, this is impossible. There is no way that you can get these first 3 lines parsed into a data structure, because it's effectively a function. Like an HTTP4S route is a function. I literally made a talk about this, trying to introduce HTTP4S, and I don't think it's necessarily bad. It's a great library. I really like it, and in Smithy4S we use it as one of the backends for our interpreters. But it has this limitation that the default DSL is just a pattern match, so you cannot analyze that statically. On the other hand, in libraries like Tapir, you actually can. This is the whole point of the library, that you get a data structure back and you can analyze it and do things with it. Now, I said it's readable for machines, but it's also readable for humans. This is a bit subjective, but I believe this is simple syntax without distractions, especially if you just look at the interface first and only then start adding like HTTP details or whatever other transport you're going to use. Because there's just 10 language features compared to 20 or 30 in Scala, probably more because I'm simplifying. So it's easy to read in pull requests, easy to see differences, but also for diffs you can automate the checking. For example, you can implement compatibility checks for your own rules, possibly. But on the human level, it's easy to read when someone is adding something, when someone is removing something, changing, and so on. It's easy to write without a specialized editor. You could literally write this in Notepad or Vim with no extensions to all the Vim people here. Because, of course, Vim is a very powerful editor. And if these are not enough for you, at least it's not YAML. Here's a bigger example with HTTP. So this is using a specific protocol called Simple REST JSON. This is something that Smithy4S supports by default. And this is a protocol that says this service is going to have operations that all need to be served on HTTP, and all the bodies will be JSON. That's basically what the protocol says. If you want anything custom against that, you need to build your own protocol definition and your own interpreters. But it's not actually that difficult. It sounds big. But Smithy4S, for example, provides you with building blocks that you can compose quite easily to get something like this, like a custom protocol or a custom interpreter. And any of this, like these rules that the protocol enforces on your stuff, this can be validated by your editor. There is an LSP server for Smithy, and there's some more tools based on it that work with this tooling in a standard way. So this is what Smithy is. Now, how does it actually solve any of these problems that I mentioned? Well, for communication, it can be a facilitator, because it's a simple language which makes it easy to communicate with it. And it's precise. It describes the API in a very precise way. There's no room for misunderstanding when you're literally working on a Smithy spec as the source of truth. So if you want to figure out how to design an API together with some client, you can get on a call, get into a per programming session, work on a Smithy spec, and when you all agree, just commit that. And this will be the source of truth. It will never get out of sync with reality. And if you miss some sort of field or something, well, you won't, because you're describing the interface at the same time as you're basically implementing it. Because when you generate code from this, tools like a compiler will prevent you from drifting away from this spec. And not only that, but also in an API-first approach like this, when you start with your specification and not your code, you can easily work with people who don't know your language, your Scala, or your libraries, like your HTTP4S or your Tapir. And neither do they need to learn your utilities that you may have over these libraries, none of that. It's a single source of truth, because you can generate documentation, client code, server code, maybe a command line interface, anything you want, you can generate from this, including Swagger UI. This exists already, like an open API spec. And this is all because the machine, your computer can read this and analyze this. And you can distribute these as files. You can put this on S3 in a GitHub release. You can put this in a jar. That's actually a legit use case. So you can put this on Maven Central or your own Artifactory instance. And it's not just easy to write once. You don't generate the code and just leave it be and then maintain it as your own code. You can continuously generate the code and then implement the interfaces that it gives you. I'm not actually going to show any of the Smithy4S code, really, because I just want to give you the ideas and hopefully encourage you to look up the documentation, which is much better than anything I'm going to say. Smithy is language agnostic. We already know that. And I know we love Scala here. We all love Scala and would like everyone to use it. But there's more to life than Scala. There's mobile devices, there's front-end. And we've had talks about Scala.js before, but some of the drawbacks have been mentioned. It's not easy to convince a whole team to switch from TypeScript or JavaScript to Scala.js. And on mobile, don't even try. It might actually not be a good idea, because try to imagine the pool of people who know both iOS and Scala. There are no leaky abstractions from your language, because you don't use your language to define your specs. And what I mean here is that sometimes you can see, just by looking at the API responses, you can guess which library was used. This used to be the case with Circe, but then sort of everyone started using the same union encoding, so it's not always true anymore. But it doesn't exist here because there is no programming language used to define the specs. And last but not least, you can forget about the routing DSLs, which use advanced language features like implicits, pattern matching, macros, any of that. It's just simple, opinionated information here. So this is where Smithy4S shows up. It's a library for generating code and working with it, from Smithy to Scala. It generates readable, dependency-free code and metadata from the Smithy specifications. The only dependency is Smithy4S core, which has no other dependencies. And it's designed for extensibility, just like the Smithy language, with no vendor lock-in or AWS dependencies, none of that. It actually compiles to the generated code and the runtime of Smithy4S compile to Scala.js, Scala Native, and Scala JVM. And by default, there's a module that you can pull in which has interpreters for HTTP4S, and you can build your own. There's Play support somewhere out there on GitHub. I've built one internally for AKHTTP in a previous job. And I was just beginning with this, and it took me 2 days. So it's literally not that much work to do. And nowadays, it's just getting easier because of some work in Smithy4S. So for the protocol that is built in, the simple REST JSON protocol, you get an HTTP4S client server and a decline CLI interface, a command line interface, for virtually free, and a Swagger UI page. To give you a better look, yeah, I'm sorry about the font size. Maybe I can do something about it. Maybe it will format better. No. OK. Forgive me for the formatting here, but what you get is basically you give the library your business logic, and you get routes back. There's no HTTP-specific code in your business logic whatsoever. It's just these interfaces, and you get something that you can just plug into HTTP4S and serve. For the clients, it's the opposite, because you give this code your runner, your HTTP4S client, and you get this high-level business logic-like interface. You can actually compose these functions, which gives you like a proxy. So I think that's pretty cool. In reality, this looks more like this, because you need to use this builder for this protocol. Like that's the interpreter that you're calling. You get the routes, you give it to your HTTP4S server, and run that. For the client, pretty much the same. You build a client, you pass this to the builder, you get back this high-level interface. If you want a Swagger UI page, it's also like a one-liner, and you, again, get routes. So here are some links for the slides. I also have a YouTube channel, so check that out, and a blog, which I sometimes update, recently more often than before. And some documentation links here. There is even a blog post series by my friend Anton Sviridov. The Smithy4S full stack is very funny and very good, so check it out. And this is pretty much all I have. I have a bonus section, but we don't have the time, so I'll just record this and put it on YouTube, so we can catch up later. So I hope this encourages you to learn Smithy and take a look. Maybe it is going to be useful for your organization. Probably not for small projects. I wouldn't recommend it. Use Tapir instead if you just use Scala backends. And I'm planning a YouTube series for YouTube, so this might happen. So thank you for coming, for sitting through all of this. And I hope you have an amazing conference. And yeah, this is it. Maybe we have time for questions.
Thank you for an amazing talk on the amazing conference. Are there any questions? The amount of stairs today.
Hi. Swagger is a popular way to communicate the API. Like, does Smithy allow you to convert the API that you define to be exported to Swagger?
OK, so if I understand the question correctly, like how is this different from Swagger?
No. Can we generate Swagger from what we have defined on Smithy?
Yeah, this is it. You can actually generate Smithy from OpenAPI. Like, it's not an accurate conversion, but there are tools for this. If you want, I can give you a link later on. It's called Smithy Translate. Oh, that's the bonus session. We don't have time for that. Watch out for the YouTube announcement.
OK, there's another question.
Hi, thanks for the talk. So I actually have a question. How does it compare to Swagger or other similar solutions like Protobuf or Apache Drift?
That's in the bonus section. Basically, we have comparisons against OpenAPI and, for example, gRPC. Basically, it's a different use case from gRPC. Like, this kind of protocol has, or Protobuf, it has a very specific use case, and like binary data. You can actually use Smithy to define a spec that you will later translate into this. Yeah, but for example, if you compare to OpenAPI or Swagger, this is bound to HTTP. There's no way to escape that, and Smithy is just like abstracting away from that.
All right, we have 45 more seconds. Is there a question? Yeah, one more, two more. I don't know. Let's pick one.
Yeah, so does Smithy have support for migrations like backward compatible, forward compatible, setting fields as deprecated, yeah, and so on?
So it doesn't have like a feature for migration specifically. It has like this annotation for deprecated endpoints, and most tooling understands it. We added this to SMITHY4S quite recently, that the generated code also has these deprecation annotations. So that should be an easier way to get people off your APIs. There are compatibility checks in the standard tooling, but they are quite biased towards binary compatibility of like SDKs, which is not a surprise given it's coming from AWS. And for example, we are internally implementing our own compatibility checks because this isn't sufficient. And it is quite a lot of work, but we hope the situation will improve. Maybe AWS releases something more general purpose, and if not, we might. So yeah, okay, we have no time. Thank you. And
All right.
yeah.
Thank you, Jakub, very much.